You're at a dinner party. Someone's brought their 4-month-old. The baby is sitting in a little bouncy seat at the end of the table, and for the last 10 minutes, they have been staring at you. Not glancing, not casually looking around the room and occasionally landing on your face, staring. Locked in, unblinking. The kind of eye contact that if a grown adult did it from across a restaurant, you'd quietly ask for the check and leave through the back. You wave, nothing changes. You make a face, they don't react. You look away deliberately, wait a few seconds, look back, and they're still there. Same intensity, same locked-on focus, like they've made a decision about you and they're in the middle of executing it. Everyone at the table laughs. Someone says, she likes you. Someone else says, babies just do that. You smile and reach for your wine and move on, because what else do you do? But here's the thing that nobody at that table mentions, because nobody at that table knows. That stare you just received was not random. It was not cute and meaningless. It was not the baby equivalent of zoning out. That baby was doing something to your brain in real time, something measurable, something that researchers at two of the most prestigious neuroscience institutions in the world spent years trying to understand. And what they found when they finally figured out what was happening inside that tiny skull during those long, unblinking moments didn't just change how we understand babies. It changed how we understand consciousness itself. And the strangest part, the baby knew what they were doing before any of us did. Let's start with the explanation that sounds the most logical, because it's the one almost everyone reaches for first. Babies stare because their vision is underdeveloped. Their world is blurry, faces are high contrast and interesting, and since they can't focus on much else clearly, they fixate on whatever's closest and most visually stimulating, which, if someone is holding them, happens to be a face. It sounds completely reasonable, and it's partially true. Newborns do have a limited focal range of roughly 8 to 12 inches, which conveniently maps almost exactly to the distance between a cradled baby and the face of whoever's holding them. There's something almost poetically calibrated about that. But here's where the vision theory runs into a problem it can't explain. By 3 months old, an infant's visual range has expanded substantially. They can see the ceiling, the window, the dog stretched out on the rug, the houseplants, the television, the stack of mail on the counter that's been there for 2 weeks. They can see all of it. And yet, given the option of looking at literally anything in the room, they keep choosing the face every single time. That's not blurry vision driving to behavior anymore. That's preference. Deliberate, consistent, unmistakable preference. And when developmental researchers started asking why, when they stopped accepting babies are just like that as an answer and actually put the question through scientific rigor, what came back from the data was something nobody in the field had predicted. Something that changed the entire framework for how we understand what a baby is actually doing when they look at you. In 2017, a research team at the University of Cambridge published a study in PNAS, Proceedings of the National Academy of Sciences, which is, if you're not familiar, roughly the scientific equivalent of getting something on the front page of every newspaper simultaneously. What they wanted to measure was something called neural synchrony, whether the brainwave activity of two people could become coordinated during face-to-face interaction. They used a technique called functional near-infrared spectroscopy, which tracks blood flow in the brain as a proxy for neural activity. It's non-invasive and works even when the subject is, say, a 4-month-old who cannot be asked to hold still inside a traditional brain scanner. They measured brain activity in both infants and adults during normal face-to-face interaction. They looked at what happened when the adult looked away, what happened with a neutral expression versus an engaged one, and what happened specifically during mutual gaze, that moment when both people are looking directly at each other. The results stopped the field cold. When a baby locks eyes with you, when that stare happens and you hold it, their brain waves begin to synchronize with yours. The same frequencies, the same rhythms, firing across two separate brains at the same time. When the adult looked away, the synchronization dropped. When the face went neutral, partial sync, but mutual gaze, real, sustained eye contact, produced the strongest neural coupling the researchers had ever recorded between individuals of different ages. Let that land for a moment. The baby isn't just looking at you. They are locking their developing brain onto yours. They are using your neural activity as a scaffold, a living, dynamic template for building their own brain's architecture. That stare, the one you laugh off at dinner parties, is how human brains teach other human brains how to be human. You are not just an interesting face to look at. You are infrastructure. But here's where it gets genuinely strange, because babies don't stare at everyone the same way, and the reason why reveals something about infant cognition that researchers at Harvard found deeply counterintuitive when they first saw it. A team at Harvard Medical School ran what sounds like a simple experiment. They showed 3-month-olds two faces side by side, a stranger's face and the face of their primary caregiver, the person who held them most, fed them, put them to sleep, the most familiar face in their world. The infants looked longer at the stranger, which seems completely backwards. You'd expect them to prefer the familiar face, the safe one, the one they know, but the data said the opposite, and consistently enough that it wasn't a fluke. The explanation comes from a concept called the violation of expectation response. Babies, it turns out, stare longest at things they haven't fully processed yet. The stranger is a puzzle, novel input, unresolved, still being mapped. The caregiver's face, by 3 months, is something the baby has already spent thousands of hours studying, every expression, every micro-movement, the specific way the corners of their mouth shift before a smile fully forms, the way their eyes change when they're tired versus when they're genuinely delighted. When that baby looks at the stranger, they're still building the file. When they look at you, their person, they're not confused, they're reading, fast, fluent, like someone skimming a document they've already memorized. Researchers at the University of Washington pushed this further and found that by 5 months, babies can reliably distinguish between a genuine smile and a fake one. Not in any way they could articulate, but in the way they respond. The fake smile gets a different reaction than the real one. By 6 months, they're doing something researchers call social referencing, actively checking the adult's face before deciding how to respond to something new or uncertain. A loud noise goes off. They look at your face before they react. You look scared, they freeze. You look calm, they look back at the source of the noise with curiosity instead of alarm. You look excited, they reach toward the thing. That long, unblinking stare isn't admiration, it isn't zoning out. It is data collection at a speed and resolution that no camera system we've ever built comes close to matching. Your baby is constructing a real-time emotional map of your face, updating it continuously, and using it to decide what is safe, what is dangerous, what is worth exploring, and what is worth avoiding. You are not just their parent. You are the external nervous system they are running their threat assessment through. And then there's the experiment that changes everything, the one that sparked years of ethical debate when it was first published, because watching the footage is deeply uncomfortable in a way that's difficult to explain until you've seen it. In 1975, a developmental psychologist named Dr. Edward Tronick at Harvard designed what became known as the still face paradigm. If you haven't seen the footage, and you should find it and watch it, the setup is deceptively simple. A mother sits facing her infant. She interacts normally, talking, smiling, responding to the baby's sounds and movements. The baby is completely engaged, kicking, vocalizing, making eye contact, smiling back. Everything you'd want to see from a healthy, connected infant. Everything looks normal and warm and fine. Then, on cue, the mother goes blank. Still face. No expression, no response. Eyes open but empty of anything the baby can read. She's present in the physical sense and absent in every other way. The next 90 seconds are what the research team spent decades studying. The baby notices immediately, not gradually, not eventually, immediately. And they begin doing what has always worked. They try to re-engage her. Big smiles, pointed fingers, the specific sounds that usually get a response. They're not distressed yet. They're just running through the toolkit, trying to find the input that produces the expected output. Nothing. They try harder, bigger gestures, more urgent sounds. They reach toward her. They look away and look back as if resetting might help. Still nothing. And then, within 90 seconds, consistently across hundreds of replications of this study, the stress response begins. Cortisol levels spike, heart rate elevates, some infants cry, others go flat in a way that's harder to watch than the crying. A withdrawal, a shutdown, an emotional blankness that begins to mirror the mother's own blank face. When she re-engages, when the expression returns and she reaches for them, recovery is rapid, but not instant. There's a lag, a period of adjustment where the baby seems to be checking. Is this real? Is it going to hold? Dr. Tronick's conclusion, after 2 decades of running this experiment, babies are not passive recipients of care. They are active participants in a continuous emotional conversation. And that conversation happens almost entirely through the face. The stare is not the baby receiving information. The stare is them transmitting it, waiting for a response, and building an internal model of the world based on whether or not the response comes. They are talking to you with their eyes, and what happens in their developing brain depends heavily on whether you talk back. Stop for a second, because something important needs to be said before we go further. The still face paradigm is used in research settings under controlled conditions with immediate re-engagement and careful monitoring. 2 minutes of still face in a lab does not harm a child. The point of mentioning it is not to make parents anxious about every moment of distraction. It's to make visible something that is normally invisible. How much is riding on those ordinary, unremarkable moments of eye contact that happen dozens of times a day? The bath, the feeding, the moment in the grocery store checkout line when you look down at the baby in the carrier and they look up at you and you both just hold it for a second. Those moments aren't decoration. They're not the soft, warm extras that sit alongside the real work of parenting. They are the real work. They're construction. And what's being built is something that researchers at MIT's Department of Brain and Cognitive Sciences spent years trying to measure precisely, because the results, when they came in, were more significant than even they had expected. The MIT team was studying what they called contingent face-to-face interaction, meaning interactions where the adult notices what the baby is signaling and responds to it in the moment, accurately, rather than on a delay or with a generic reaction. Not just being present and responsive. They tracked this across the first 6 months of life in a group of infants, then measured brain development at various intervals. Specifically, they looked at the prefrontal cortex, the region of the brain responsible for planning, decision-making, emotional regulation, impulse control, and complex social behavior, the part of the brain that takes roughly 25 years to fully develop, the architecture that runs adult cognition. What they found was measurable. Babies who received more contingent face-to-face interaction in those early months showed greater prefrontal cortex development, not marginal differences, measurable ones, visible in the imaging data. Which means that every time you hold a baby's gaze, every time you mirror their expression back to them, every time you notice what they're communicating with their face and respond to it, you are not just connecting with them emotionally, you are doing something structural. You are building the hardware, laying down the physical infrastructure that will support their cognition, their emotional regulation, their capacity for complex social relationships for the rest of their life. The stare is not asking for attention. The stare is asking for construction materials. And your face, your responses, your attunement, the way you look when you look back, is what you are providing. Think about what that means in terms of the ordinary moments that don't feel significant. The morning feed when you're half awake and your eyes meet and you smile without really thinking about it. The afternoon when you're reading something and the baby makes a sound and you look up and they're watching you and you make a face at them before going back to what you were doing. The car ride when you glance in the rearview mirror and catch their eyes in the reflection and you hold it for a second. None of those feel like brain development. None of those feel like anything, really, just the texture of daily life with a small person. But each of them is a moment of contingent interaction. Each of them goes into the ledger the baby's brain is keeping. Each of them is, in a very literal neurological sense, part of the build. Here's something that changes how you see the whole picture, and it's something that's easy to miss until someone points it out directly. The babies who stare most intensely, most persistently, most insistently aren't the ones who need something from you in the transactional sense. They're not always hungry or tired or uncomfortable. In many cases, they're calm, they're fine. They just want your face, because your face is the most information-dense object in their environment. Think about what a human face contains. Hundreds of muscles capable of thousands of distinct combinations, micro-expressions that last fractions of a second, color changes in the skin that respond to emotion, eye movement patterns that signal attention, interest, fear, joy, the specific way someone's brow draws down when they're concentrating, the way the eyes go soft when the smile is real. An adult looking at another adult's face processes all of this in milliseconds and mostly unconsciously. We're so fluent in faces that we don't notice how much we're reading. A baby is learning to be that fluent from scratch, and they're doing it in the most time-constrained environment imaginable. The brain's plasticity window, the period when the architecture is most flexible and new learning takes hold most permanently, is not open indefinitely. It has a timeline, and the baby, without knowing any of this, is doing exactly what needs to be done, getting as many reps in as possible while the window is open. Every stare is a training session. Every mutual gaze is a rep. Every time you look back, really look, not just aim your eyes in their direction, but actually meet them. You're handing them data they use to build processing speed, pattern recognition, and emotional vocabulary. This is what 15,000 years of evolution built those round, wide, irresistible eyes to accomplish. Not to be cute, though they are, not to trigger caregiving instincts, though they do, but to initiate and sustain the specific kind of face-to-face engagement that builds a human brain. The eyes are a feature, not a byproduct. A therapist in her late 30s described it to me once in terms that have stuck with me ever since. She said that in her clinical work, the thing she watches for first, before anything else, is what happens when a caregiver walks into a room. Not what the baby does in response to a stranger, not how the baby handles a novel toy or an unfamiliar sound. What happens in the baby's face in the first 3 seconds when their person enters their visual field. There's a particular thing that happens when attachment is working the way it should, she said. The face changes. Even before the baby moves or vocalizes, the face changes first, like a light coming on in a room that was dim, and that change tells me more than almost any other single piece of observation. She's watching for the face lighting up because that response, fast, involuntary, face first, is the output of a system that has been carefully built through thousands of iterations of exactly the kind of contingent interaction the MIT researchers were measuring. It doesn't happen because the baby has been trained to perform it. It happens because the baby's brain has learned, through repetition, that this particular face is the most reliable source of information and safety in their world. And the inverse of that, the baby whose face doesn't change when their person enters the room, or changes only slightly, or seems to treat the caregiver's arrival with the same mild interest as any other new input in the environment, is something that Claire says she takes seriously immediately. Not because it guarantees anything, but because it tells her to look closer. This brings us to the part of this video that matters most, practically speaking, because everything we've covered so far is about what normal, healthy staring looks like and what it's doing neurologically. But there's a reason researchers keep returning to early gaze behavior as a clinical marker, and it has to do with what the absence of it indicates. A baby who consistently avoids eye contact, who doesn't track faces, who looks through people rather than at them, who doesn't show the orientation toward the caregiver's face that we'd expect across the early months, that pattern is one of the earliest observable signals that something in the social development system may need attention. Pediatric neuroscientists are careful about how they frame this, and so should we be. Every baby develops on their own timeline. Some babies are naturally less intense in their gaze behavior than others. Variability is normal. The absence of intense staring does not mean something is wrong. But consistent, pervasive avoidance of face-directed gaze, not just occasional, not just on bad days, but as a pattern, is something that researchers at the American Academy of Pediatrics and multiple developmental neuroscience labs identify as worth investigating early. Why early? Because of the same reason the staring matters in the first place, the brain's plasticity window. The prefrontal cortex development, the neural scaffolding, the brainwave synchronization, all of that depends on the kind of contingent interaction that gaze behavior both drives and reflects. The window for that kind of deep, rapid architectural development is not open at the same level after age 2 as it is before it. Intervention at 6 months produces results that the same intervention at 2 years cannot replicate, because the building is further along and the most flexible phase of construction is over. Early identification doesn't mean early alarm. It means early access to the support that works best when it's offered at the right time. And if something about your baby's gaze behavior feels off to you, not just different from what you expected, but actually specifically off in a way you can't quite articulate, trust that. You are without question the most finely calibrated instrument on Earth for reading your own child's face. You have been watching it longer and more closely than anyone else alive. Your instinct about it is built from more data points than any single clinical observation could provide. If something feels off, that feeling is worth following up on. The cost of checking is low. The cost of not checking if something is there is not. So let's bring it all the way back to that dinner party. The baby in the bouncy seat at the end of the table, that locked, unblinking, slightly unnerving stare, the one that makes every laugh and say, "She likes you," before moving on. Here's what's actually happening in that moment, at the level of the biology. That baby's brain is reaching out for yours. They have selected your face, probably because you made eye contact first, or because you're physically close, or because something about the way you looked at them when you walked past activated the response, and now they are using it. They are, in the most literal neurological sense possible, using your face as a scaffold for their developing neural architecture. They are trying to synchronize their brainwaves to yours. They are collecting data on your microexpressions, building pattern recognition, running you through the same evaluative process they run every face through, but with a particular intensity, because eye contact is when the synchronization happens most strongly, and their brain knows this, even though they don't. They're not judging you. They're not confused by you. They are, in the most fundamental sense possible, connecting to you, trying to link their developing consciousness to yours and learn something from the contact. And what happens in their brain over the next few seconds depends on what you do next. If you look away, the synchronization drops. If you hold the gaze, if you look back, really look, and hold it, the coupling strengthens. And if you add to it, make an expression, change your face, respond to something you see in theirs, you've just given them a full contingent interaction, a rep in the training session that their brain is running every waking hour. That's what the wave and the weird noise accomplishes, by the way. When you make a face back at a staring baby, you're not doing something silly. You're doing exactly what their brain was asking for when it locked onto you. You're responding, you're reflecting, you're completing the circuit. There's a question I want to leave you with, and it's one that I think lands differently after everything covered in this video. We talk a lot about screen time and its effects on children, how much is too much, at what age it starts to matter, what kinds of content are better or worse, and that conversation is worth having. But there's a quieter version of that same question that gets far less attention. Not how much time is my child spending looking at a screen, but how much time is my child spending looking at my face, and how much of that time am I actually there for it? The brain synchronization that the Cambridge researchers measured, the neural coupling that builds cognitive architecture, that happens through mutual gaze, both people present, both engaged, both actually there. A face that's technically in the room, but whose eyes are somewhere else, or whose expression is distracted or flat, produces a different neurological experience for the baby than a face that's fully present and responsive. This is not an argument for guilt. It's not a claim that every distracted moment leaves a scar. Parenting is relentless and complicated, and no one is fully present every second of every day, nor should they be expected to be. But it is a case for taking the ordinary moments seriously, the moments that don't feel like anything. The glance over the coffee mug in the morning, the look that happens naturally during a diaper change when you're both just sort of there together, the eye contact across the grocery cart that you didn't plan and that lasted maybe 3 seconds before you both moved on. Those moments are not trivial. They are, according to the best developmental neuroscience we currently have, exactly how the most important parts of a human brain get built. Every time you look back, really look and let it land, you're doing construction work. You're providing the scaffold. You're completing the circuit that a baby's brain is reaching out to close. That's not a small thing to be offered the chance to do. The next time a baby locks eyes with you across a room and just holds it, remember what you're actually being invited into. Not a social nicety, not a cute moment for the group chat, an invitation to synchronize, to teach a brain through the most ancient interface that human beings have what it means to be seen by another person. 15,000 years of evolution didn't give babies those wide, round, irresistible eyes by accident. It built them to do exactly this, to find a face, lock on, and start the process of becoming human. The only thing they need from you is to look back. If this changed how you see the babies in your life, leave a comment below. Tell me about a moment when a baby's stare stopped you completely, that pause where you felt something happening that you couldn't name. Because now you know what it was, now you know what they were doing, and now you know what you were doing in return every time you looked back. And one more thing. If you've ever been in a room at 3 in the morning and found a baby staring at an empty corner, laughing at nothing, completely delighted by something that isn't there, the neuroscience behind that is genuinely strange, and it has nothing to do with the explanations that get passed around at the family dinner table. That's the next video, and fair warning, the answer involves more layers of infant brain science than you'd expect, and one finding that made researchers sit down and rethink a fundamental assumption about early consciousness. Worth waiting for.